This week, we're looking at the OCaml compiler and extending the reach of that compiler, because whilst OCaml has always been a backend language, it's got its sights set on your browser too. I'm joined for this by António Montiero, who's been doing a lot of interesting, sophisticated compiler work to help OCaml grow out into the world of JavaScript, but also to help coax some existing JavaScript developers into the functional world of OCaml. And he's doing that by extending OCaml's compiler on two different fronts. First, he's the creator of Melange, which will let you write OCaml and have it produce JavaScript. And second, he's a major contributor to ReasonML, which lets you write something that looks an awful lot like JavaScript, but emits type-safe, back-end native OCaml. Now, of course, the first question is, why? Why would you want to do that? What's so great about OCaml that we should put it in the browser? And what does Antonio find so great about it? What's his personal reason for all this work? But the much juicier question is, how's it done? How do you compile and transpile between two different languages? Because obviously parsing for loop syntax in one language and emitting a different for loop syntax, obviously that's trivial. But how do you handle the major differences, like different concurrency models? Or how do you port OCaml's first-class module system to the JavaScript world? To answer those questions, we need to start picking the brains of an expert. So, I'm your host, Chris Jenkins. This is Developer Voices, and today's voice is António Montiero. Joining me today is António Montiero. Antonio, how are you?
Pretty good. How's it going?
Very well, very well. You're going to take me into a world I don't often, in fact, I've never visited. I've just skirted past the coastline of, which is OCaml.
Very excited.
We're going to have to go through a big list of OCaml projects you're involved in, but it's fair to say you're up to your neck in OCaml, right?
I'd say that. I think it's been, you know, like maybe like TCP, like a slow start, and then really fast catch up.
So what's your origin story? What lured you in?
I think I first got my contact with OCaml in college. So this would have been probably about like 13 to 15 years ago, and there was a class in OCaml. I sort of like, it was very different from all the languages that we had been learning it up until that point. And then I kind of liked it, but then I put it aside because all we had to do was implement some like kind of class project that was very self-contained. I didn't see the value in the real world. And so it wasn't until I think 2016 when I saw ReasonML actually on Hacker News that I sort of looked at it again. So I saw the project ReasonML announced by Jordan Walk, who also created React.js at Facebook. And the name sounded familiar. It's like, oh, I've heard this word OCaml before. Like, why are they putting a new face on it, or why does it need it, and what can I do with it? And I decided to take it for a spin. And honestly, it was a very rough experience. It was really, really like rough to get started, to get installed. The ecosystem wasn't there. The build tooling wasn't there. Really, really, hard to get started with. Which I'd say is, I'd understand why not a lot of people use it at that point. But then I kept playing with it. And I kept understanding the language concepts. I joined some community Discords and Slacks. I got some help, different ways of installing, tried different tooling, and eventually it clicked. And I'd say the reason why I keep using OCaml today is for all its merits, right? So it has a very ergonomic type system. It infers very, very good type inference based on Hindley-Milner. It has I'd say a wide community these days. The module system is great. And even if you can't find, it's honestly hard to explain because it's such a familiar feeling when you try OCaml in like a program that you can define in like types and like what they call algebraic data types, basically. And you can sort of derive your program from the types that you defined. Everything compiles, and then you have a working program. That's sort of like a magical feeling, a good like dopamine injection that really sort of like, I don't know, I'd say like keeps you going and keeps you like writing more and trying more things with the language. Even if you don't have a library that can be like that exists for a particular use case that you have in OCaml, it has a very good like FFI, foreign function interface story to C, for example. So you can always model your program as if with some like and link against some C library, for example, or C++, or even like Rust these days, and so you can call between one and the other.
Okay, this actually reminds me. There's a lot of overlap between that and my story with Haskell, and I guess it's like which of those two languages your university teaches you as the weird functional language, right?
That's right.
Was there a particular moment when the penny dropped with OCaml? Was there something that slipped into place and you understood it?
I think we'd have to go back to the BuckleScript project. Okay. This was a project I think started at Bloomberg that the goal was to compile OCaml and ReasonML to JavaScript. Okay. When I got started with OCaml, I think that would have been the most polished workflow at the time for people like me who hadn't used OCaml before and didn't know a lot about like compiling. Like for context, like I had been a JVM JavaScript, a JavaScript and a JVM programmer because I used Clojure extensively, and my experience was interpreted languages. I had only done a little bit of C in college, using probably a Makefile, something like that. So coming to like a compiled language and the workflow there was sort of a bit different to me. Especially like I had also used like Golang before, but like everything in Golang is super well integrated with like one single command. In the case of OCaml, everything felt a bit spread out. Everything felt a bit fragmented in some sense. And BuckleScript was really trying to unify this experience together. This was something that they were heavily working on. Even inside Facebook. I think at some point, Messenger.com was written. I think the stat was like 50% was written with ReasonML and compiled with BuckleScript. So that's, I think, where it clicked for me. I tried BuckleScript. It was an npm install away. I could see OCaml, several OCaml modules. This sounds really trivial today with the tooling that we've gotten, but I think at the time it wasn't right there. It wasn't necessarily there, and definitely not for me. But just the ability to put together a few libraries, a few modules, work and get like a working JavaScript program was really what clicked for me. And then from then on, like my entire quest was having the same experience in native programs.
Yeah. It's like something about the language. Like if you can compile it, it works, provided you can get the flipping tool chain to give you the same experience, right? So you mentioned BuckleScript. Now, I'm coming as an outsider, not really understanding the OCaml ecosystem, but you've got ReasonML, which is a syntactic front end, and BuckleScript, which is a compilation backend. BuckleScript might be a defunct project or a rebranded project, or
yeah, I can give you a rundown.
Give me the lay of the land.
Absolutely, yeah. So what I really got started with was ReasonML from seeing it on Hacker News, and I decided to try the language. I think to take a step back, right? OCaml is an umbrella word, I'd say, for many things. We can start by the OCaml compiler, which is this tool chain that allows you to take OCaml, the syntax, and compile it into native programs and run them, or bytecode programs, because it has two. Like the compiler actually ships with two backends.
Okay.
Like write a bytecode virtual machine and a compiler that compiles programs to native assembly. The thing about OCaml is very pluggable, especially on the compiler front end. And when I'm saying compiler front end, I mean the syntax, the preprocessor extensions, right? And what ReasonML was, what ReasonML still is basically just taking the surface syntax and replacing it with something else. So instead of writing like the OCaml language, you write ReasonML, which is a language that is more closely familiar to people who've used like algol syntax before. It looks a lot like JavaScript or C, or Rust or Go.
Yeah, the default familiar to programmers syntax.
Exactly what everyone sort of learns these days, or at least is familiar with at some point. This is what ReasonML is. It's just a different syntax altogether for OCaml.
Okay.
BuckleScript, or let's take another step back, which is let's go to the compiler backend now, right? I mentioned that the OCaml compiler ships with a bytecode virtual machine and the ability to compile programs to native assembly. There's also tooling to take some kind of intermediate representation that the compiler produces and compile that to JavaScript.
Okay.
The first one that ever existed, to my knowledge, is a tool called JS of OCaml. And JS of OCaml takes the OCaml bytecode, the same bytecode produced by the bytecode virtual, that is interpreted by the bytecode virtual machine, interprets that bytecode at compile time and produces JavaScript that you can run on the web or wherever JavaScript runs.
Okay, yeah, I can see that.
Right? We can go into advantages and trade-offs later, but just to keep giving you the lay of the land, what BuckleScript did was hook into an earlier compiler intermediate representation that looks a lot more like the Lambda calculus, if you're familiar with that.
Okay, yeah. So we're AST and a couple of steps down, presumably?
Exactly. So,
yeah.
So I would say the order would be something like syntax, which would be OCaml or Reason, abstract syntax tree, and then type inference, like when the type checking algorithm runs. You augment this abstract syntax tree with a typed abstract syntax tree, right? A type tree. At which point you have all the information, all the static information that you're ever going to have about your program. So you just throw all the types away when generating the Lambda intermediate representation.
Right. Yeah.
Right. So the Lambda part of OCaml doesn't have any types. They're thrown away between type checking and like Lambda generation, let's say. But it does have a lot more information than the bytecode intermediate representation, which is why BuckleScript then chose to hook into this earlier intermediate representation, the Lambda, rather than the bytecode.
Okay.
To answer your other question, why BuckleScript is a defunct project, I think around 2020, there was this sort of a rebrand into, I'd say mostly for marketing efforts, where the people behind BuckleScript wanted to take the project into a different direction, which was really like a break from OCaml. And what happened was BuckleScript renamed to ReScript, which is a language you might have heard as well. Yeah. So rescriptlang.org, it's a great language. It's like sort of the natural successor to BuckleScript in some sense. It is, though, like by not OCaml at all. even if it's built in OCaml and has some historical like precedence there, it is a different language that compiles to JavaScript, and a lot of people are using it.
Okay, so it's not just that. It's no longer just a final compilation phase. It is entirely its own separate thing.
Exactly. I think I'm not as familiar with it these days as I could be, but to my understanding, it sort of hooks into the same intermediate representation. It still is backed by the OCaml compiler. Is basically a fork of the OCaml compiler that produces JavaScript, but it made a whole different set of choices. It made it took the project in, I'd say, a different direction. And I'd say the major thing that they've shipped recently is the removal, effectively, of currying or partial application.
Oh, okay.
One thing, so like OCaml is, you mentioned you're familiar with Haskell, and Haskell obviously has this too. Every OCaml function, just like every Haskell function, is automatically curried. And what I mean by that is if you have a function of 3 arguments to a return result, you can decide to apply only 1 argument, at which point you get a function of 2 arguments to the result, right?
Yeah.
And this is something that works really well in languages like OCaml or Haskell. But the maintainers of ReScript, I think, decided that when you're compiling to JavaScript, it's more familiar if you have functions as they exist in that environment as well. And so I believe they are now uncurried by default. And so that's a big break, for example, from OCaml programs.
Okay. That feels like, as an industry, we're not quite ready for that holy war. Like, it's maybe 10 years away before everybody has an opinion on whether it's good or bad.
That's a fair point.
But for now, so you're giving me the impression that the OCaml compiler chain is very pluggable.
It is.
Yeah? So is that well architected and designed to be taken in pieces?
I don't know about that one.
Okay.
I think I don't know if I'm the best person to make that judgment either. I know it is very pluggable in the sense that, at least from a syntax perspective, as I described, you can sort of switch syntaxes. As there's also another part that people would be familiar as macros, right? They're called, in OCaml, they're called PPX, or pre-processor extensions.
And what kind of macros are we talking?
These are AST level macros. So they are
the good kind.
Not exactly. I guess not like C preprocessor macros, for example, but more like I guess also not really Rust level macros, because I think those are defined a different way. I'm not too familiar with those. I know they take AST as well and transform it in some sort of way. But in OCaml,
sure, this is sounding like Lisp style macros.
Yeah, I guess Lisp style macros would probably be a fair comparison here, even though Lisp is, obviously like homoiconic and untyped, and probably a lot easier to manipulate the AST than in something like OCaml, where the AST is very much like an algebraic data type, right? And so it has many variants or enums or cases,
right? Yeah,
and the surface area is quite large, and so writing a macro or a PPX in OCaml is not always straightforward because of that. Because you have to decide which language construct, right, which syntax construct you want to hook into. You want to modify that, produce a new version of that syntax node, right? And also, you don't really have access to typed information about the program. You can't really query other parts of the program in the default case, right, for macros, because they just work at the syntax level.
Okay, yeah.
Sorry. I was just going to mention, I mentioned like this part. Yes, they're very pluggable, and there are libraries to help you with that. But the other parts, I don't think are as pluggable. So, for example, if you want to hook into the bytecode, I believe that works because it's like the final output of a program when you're compiling to bytecode. But if you want to hook into like the type tree, or if you want to hook into the lambda representation, I think at that point you'll find that you're going to be writing a compiler fork.
Right. Okay. So that does lead into one of your big projects, which you have done this, right? You've hooked into creating a different compiler backend.
That's correct.
Melange.
Yes. So I mentioned previously how BuckleScript sort of broke away from OCaml in a sense to create ReasScript. I was personally very into the OCaml part of the ecosystem and wasn't quite ready to let that go.
Okay.
So at that point, and I think this would have been probably almost 4 years ago to the day, I forked BuckleScript before it became ReasScript. And right. I know this is confusing. So to reiterate again, as BuckleScript, which compiled OCaml and ReasonML to JS, became ReasScript Lang, this new language that wanted to take both syntax and compilation in a new direction. I kind of wanted to stay with the BuckleScript ideology of things, if you will.
Right. Yeah.
Which to me is more naturally closer to OCaml than what came after, right? And so,
right. Yeah.
So we forked BuckleScript and wanted to keep working on it and keep making it better for the OCaml community. Another way to look at this would be if you're someone who writes JS for a living, for example, like you're a JavaScript developer.
Yeah.
You're familiar with the entire ecosystem. You like to install things from npm. You'd probably go with ReasScript these days because ReasScript is an npm install way, and you can try a new compile to JS language in your own programs. However, if you're an OCaml programmer and you want to produce, you're very familiar with OCaml and its ecosystem, you want to produce JS that is not only modern, but also amenable to being parsed and transformed by all the modern tooling in the NPM world. This is where you'd use Melange, this project that I started.
Right. So the broad division is: are you a JavaScript programmer wanting to get closer to OCaml, or an OCaml programmer wanting to get out to the browser?
I think so.
Roughly.
Yeah, I think that's a very fair statement.
Okay, so what does a tool chain for the average OCaml programmer wanting to be in the browser look like?
Yeah. So Melange works very similarly to how BuckleScript used to work as well. However, one thing that we did change is how it interacts with the rest of the OCaml platform. And I think this is the biggest selling aspect for Melange, one of the biggest these days. The way Melange works is at the compiler level, right? It can take any syntax, it can take any abstract syntax tree, just like the OCaml compiler. It also hooks into this, like the Lambda intermediate representation, and then produces beautifully readable JavaScript from there.
Okay.
Right. At the ecosystem and platform level, and this is a big difference from how BuckleScript used to work back in the day, Melange is integrated with what we call the OCaml platform, and this is the official term that represents an entire set of tooling that is designed to work around the OCaml compiler and ecosystem.
Okay.
The OCaml platform has tooling to build your code, to obtain packages, to get editor integration in your editor, so like the language server protocol and such.
Okay, yeah.
It has tooling for automatic documentation generation, and probably a few others that I'm spacing out on right now.
Yeah, but all that stuff I think it's some of the stuff that actually makes writing a language hard. Because there you are, you finished writing your language, you pat yourself on the back, and you've still got to write a package manager and a build tool and all that stuff, right? Yeah.
Yeah, exactly.
Okay.
And so this was a very much intentional and very early design choice that we wanted to sort of like go back to the roots. We wanted to go back as close as possible to OCaml, because if we were able to integrate with the OCaml platform, if we were able to integrate with Dune, the OCaml build system, then we'd have access to the entire ecosystem, to all, like we'd effectively be standing on the shoulders of giants, with all the tooling that had been designed and planned and written before we came along.
Right, and you get back to that experience you had where BuckleScript was the first thing where the tool chain seemed to work for you.
In sort of a different way. Yeah, but and now we sort of go back to the roots and to the OCaml ecosystem.
Okay.
So Melange uses Dune to build your projects, which is the OCaml
as
build
an
tool.
aside, is this an OCaml theme that we have to do Frank Herbert puns?
This it might be.
Okay.
It might be. This is I can't take any credit for this, honestly. I'm not into the Dune lore,
Okay.
but a community member came up with the word melange, and I thought it fit very nicely. Also, because melange is a word in French that means mixture, and melange is a mixture of a bunch of different tooling coming together to produce JavaScript from OCaml. So I thought it was perfectly fitting, and I ran away with it. I was saying that Melange builds your projects with Dune, the OCaml build tool.
Okay.
You get your packages, your libraries from OPAM, the OCaml package manager. It uses the OCaml LSP, the OCaml language server protocol, and Merlin, which is a previous tool, the library that provides all like the type completion and information and diagnostics to the OCaml LSP. It uses ODoc to produce documentation. And you can, the other one that I forgot earlier is there's this tool called Dune Release, which you can use to package and publish your Melange projects to OPAM, the OCaml package manager. I'll actually be talking in September in Berlin about a melange of tooling coming together at a new conference called Fun OCaml.
Oh, nice.
Yeah, so pretty excited about that, and I'll get to maybe reiterate a little bit of what we're talking here, and present Melange in sort of like this unified way of all the tooling coming together.
This just makes you think, right? So I can think of maybe 2, maybe now 3 languages where I'd have a genuinely good experience if I want to write web stuff where the front end and the back end share code.
Yes.
Right? And I'm going to pick PureScript, which is niche, but I love it. Gleam, which is new, but has a very nice kind of overall ecosystem. Can I add OCaml now to my list of this is genuinely browser to server?
This is a goal. This is definitely a goal. I'd also add Clojure and ClojureScript in that mix, as it's very much designed to do that. And I've done that a ton. We've done that at previous jobs. It works really, really, really well together too. But sort of to go back on topic, and like I guess you'd use PureScript with Haskell. Is that your experience?
No, it's all compiling down to Node. So JavaScript in the front end, Node in the back end, and it's all the surface syntax is all Haskell, but the actual implementation is basically a JavaScript engine.
Is that also what you were thinking with Gleam? Or because I think Gleam also has different backends, right? I think they can compile to the...
Yeah, they can compile to JavaScript or to the Beam, which is the Erlang virtual machine. Yeah.
Got it. Yeah, I was actually thinking more in terms of... Because, okay, this might sound a bit elitist, but that is like JavaScript to JavaScript is the easy mode, I think.
Okay.
Right? where even these days, right, you can write JavaScript or TypeScript and have your front end and your backend in TypeScript or JavaScript. Just like you mentioned, you can have pure script compiling down to Node and JavaScript on the front end.
Mm-hmm.
I think what I envisioned when you talked about this was sort of like totally different runtimes running the same language, communicating with each other. And that's where like ClojureScript compiles to JavaScript, Clojure runs on the JVM.
Right. Yeah, I see.
Similarly with OCaml, and this is what I think I meant as is a goal, is you can have OCaml compiled through Melange to JavaScript. And again, like I'd say the easy mode then would be Melange compiled to Node.js on your server, which also works. But what we're really working on, we're sort of excited about, is also having the same code base with at least like parts that are shared, right? Hopefully you'd want your types mostly to be shared between the backend and the front end, so you can serialize and deserialize easily. Where a part of it compiles to JavaScript with Melange, but then your backend compiles with OCaml to native code, and you sort of run the same code base and communicate with one another.
Do you end up with like, how does that play out? Do you end up with parts of the code marked as, if I'm compiling as JavaScript, do this?
That's exactly right.
Yeah. So it's like language directives.
Those don't really exist, and sort of that's sort of one of the things that we're working on. We think we can make it work with preprocessor extensions, PPX, right? Because they're basically extensions to the language where we can add those directives, or with some support from the build system. So this is very much a work in progress. But one of the exciting things that Ahrefs are doing, and Ahrefs have been from the beginning a major sponsor to Melange and still are to this day. Okay. So I thought I'd mention them together today as well. They're like this big like search engine optimization company in the space. And they develop all their apps with OCaml. All their front end is compiled with Melange. The thing that they're doing recently is they're basically re-implementing the React.js server-side rendering in OCaml. They're implementing the new React server components, which is effectively just an RPC protocol in OCaml. And so they've gotten to this point where, I mean, this is not only a goal, but already a reality in some sense, where some of the Ahrefs web pages and the web applications, like when they get to your browser, like before React.js compiled through Melange takes over, there has been a server-side rendering process that took the same code that renders on the front end. Well, I guess, it is another interpreter, right? Like it compiles it to HTML and sends that over the wire to the browser.
Okay, so this is the thing where like the code might run in the browser and generate HTML, or you might send JavaScript over the wire and it runs and creates HTML in my browser, or you might run it locally on the server and just send the HTML part.
That's exactly right.
Yeah.
Okay. Yeah. And I'd say it sends the HTML part. It also sends the JavaScript, but React.js just takes over and installs event handlers, for example, on the JavaScript that is already on the page and compatible to what it would generate. And this is called hydration.
Right. Save me some thinking. Why is that a good thing?
The reason why this is a good thing is because historically, and I'm not really sure what the state of that today, but I'd say I think it's still subpar. But historically, like crawling engines, they did not run the JavaScript on the web page. So if you have a world where every web application is written with React.js, the first thing that you get whenever you load a HTML for a website is you get a container div that loads a script, right, with a script tag.
Yeah.
Whereas in this world, the first thing that you get is you get like the full HTML page, and then the script tag that takes over and like installs the event handlers. So you can imagine how this for a search engine optimization company feels like a very important topic.
Yeah. I've definitely been involved in a project in the dim and distant past where we had to serve up a static HTML version of the page for crawlers, just so they wouldn't list us as basically empty pages.
Exactly.
Yeah.
Yes.
Okay. Yeah, that makes sense.
That's exactly the problem that it solves.
And does this solve the problem that, but then as a developer, I don't want to think about that, and I just want to have the whole thing look like I'm writing React?
Yeah.
Yeah. Okay.
That's right. The other problem that it solves is also like in terms of like some loading metrics, right? I think, was it FCP, first contentful paint, or something like that, where if you send HTML to a browser, your page won't seem like it's loading forever or for some time, because you already have the structure there, and then the JavaScript can take over. Whereas in the other case, you're incurring the downloading of the JavaScript, the parsing of the JavaScript by the engine, and then the execution of React.js and like the HTML, sort of like the DOM generation on the front end. So it's sort of like a hack. You skip all of that, and then you're still doing all those steps, but you already have some content on the page that your users might be reading.
Yeah. Then if I can send the user all the HTML up front, I buy myself an extra second of loading time while they're looking at it.
For example, yes.
Yeah. Okay, that makes sense. So I see how that whole ecosystem fits together. What makes the job of writing OCaml internal representation to JavaScript execution engine hard? How different are they?
Yeah. What is the...
So I'm just thinking about how you implement this. You're there at the something that looks like a Lambda calculus with maybe a bit of extra information inside the OCaml compiler. Now you need to write JavaScript. That doesn't sound too... It sounds like a large job, but not necessarily a difficult job. Is that right?
So what makes, I guess, generating JavaScript from this Lambda representation hard?
Yeah.
There are a few things. I think in the best case, it isn't a very hard transformation. If you're just taking the core OCaml language, the Lambda is already pretty, I'd say, optimized for code generation. So you have like a lot of deduplication already done. You have a lot of references already resolved. You get a lot of information from the Lambda. There's some things that you don't get. And one example would be how the OCaml memory model is a bit different than how a JavaScript program would look like. One example of that would be if you have a record, and the record is just a fancy word for like a dictionary where the keys are static at compile time.
Yeah.
Right. We ideally we would want to generate a JavaScript object from a record in OCaml. Right.
Yeah, makes sense.
It's, key value pairs. The thing that we had to change, because the OCaml compiler elides between type checking and Lambda generation, for example, is we had to preserve some information about what the keys are named. Because in the OCaml memory model, if you have a record and you have access to the type, say that you have properties A, B, and C, they are laid out in order in memory, right? So you'll know that the first block is A, the second block is B, and the third block is C.
Right, so there's no need to keep the names around.
There's no need to keep the key names around. Exactly. So this is something that, because we're not doing source to machine transformation anymore. We're now doing source to source. And when you're doing source to source, there's a lot of information that you need to preserve that is otherwise not available when you're doing source to machine transformation. That's sort of like one of the early barriers that we ran into. There are some more related to, for example, I mentioned how the core language is sort of easy to compile. But what I was alluding to there is that there's all these extensions to the OCaml language, and it's not clear how you compile those. For example, the module system, where the module system is in OCaml, and maybe just to make an aside here, is really, really interesting, where every file is a module.
Okay.
And you can think of a module as just a bag of values, right? So every file, just like in other languages, right, they export a set of values. This is, I think, pretty straightforward to comprehend.
Most of those values being names which point to functions.
Or functions or values, or right.
Yeah.
The cool thing is that every module can have submodules.
Okay.
Right? So modules can have bags of values themselves. So you can have a file called a.ml that has a module B inside it, and B is another collection of these values. And they are sort of interchangeable in the sense that one is a file, but you can treat it as a module because it's a first-class citizen in the language. And while the module system is, and I'd call this, while the module language is sort of different from the value language in OCaml,
mm-hmm.
you can sort of convert between one and the other, and you can like pass modules around as arguments to functions. Like you can sort of lift them and unlift them in that sense.
So give me an example of a function you would run on a module.
Yeah. So say that you have, for example, I guess the first example that comes to mind is like an asynchronous runtime, right?
Mm-hmm.
It's an asynchronous runtime that you can think has the same signature, but it can have different implementations. So like one, you can vary the backends. And in, I think, OOP terms, this would be the strategy pattern. Not to bring up the Gang of Four. But you'd start by writing a module signature. And in this case, it'd be something like, what is the type of a future in this runtime, and what is the type for the function bind if we're doing it in like a monadic term, for example, right?
Okay.
So type would be a type T that can remain anonymous, and bind would be the usual T to a function that takes an A, produces a B of T or a T of B, right? And then the result is also like a T of B.
This is the function that allows us to chain a series of futures together.
Exactly, right. Yeah. This would be, or otherwise, a monadic bind that is, and so say that you want to pass this monad signature around, and you want to implement it in different ways. We're talking about it in asynchronous runtime, but this is really way more generalizable than that, as you probably know. So you basically define a function that takes a module having this signature. And then at every call site, you can just define your own module implementation and pass that first-class module, that's how they're called in the language, to these functions. And so...
So do I get to say,
one more thing. Inside the function then, what you would do is you would use the bind function from the module that you got as argument.
Okay, so I can say, give me any module that implements this batch of functions, and I can start using it. As long as you obey the contract for a module, exactly. I don't care who's implemented it. So it's a bit like a collection, a bit like an interface?
Yes. It's a bit like an interface. And you can implement this. You can ask me, like, Antonio, why so complicated, right? Can you just pass a record around? The answer is yes, sort of, in some cases. Sometimes it's easier to abstract with a module. Okay. It depends on whether, it depends on polymorphism, which we're not going to get into.
Okay. So this This is a challenge for compiling to JavaScript.
Some of these are. But yeah, like I guess where we started was before the big tangent on the OCaml module system, which I recommend everyone to go and try and give it a try. Some of these language extensions are more problematic than others to compile. Right. One example is, but honestly, for modules, JavaScript makes it very easy because if you squint, they sort of have the same representation, where a JavaScript module that you import, at least in the CommonJS paradigm, right, is an object is a bag of values, right? It's an object with key value pairs where keys are the names and the values are the values.
Yeah. Yeah, okay.
So we decided, okay, if we compile, sub-modules, right, modules that exist within a file to a JavaScript object of the same shape, we can pass them interchangeably.
Yeah, so in a project like this, the trick is to start figuring out what the thing in OCaml is like in JavaScript.
This is a big challenge, and this is a big part of it for sure. Where how does a representation of a value in this language map to the representation to a and I guess the choices are always like, does it map to like a readable, an ergonomic version of a structure that people in like JavaScript are familiar with, that is also performant and that we can manipulate easily through code generation.
Right. Has that been always possible, or have you had to say, look, we're just not going to support this OCaml feature, or we're just not going to emit particularly idiomatic code?
Yeah, it's well, I guess the answer is no. It hasn't always been possible.
Okay.
There are some features, especially recently in the OCaml compilers, that we don't currently support. So OCaml 5, which was the most recent big release of the OCaml compiler, for example, introduced two major things. One is shared memory parallelism. The other one is algebraic effect handlers.
Okay, yep.
As you can imagine, JavaScript being a single-threaded language, we can't really support the multi-core nature of OCaml, the new OCaml runtime. Right.
Yeah, I can see that being.
So that's a pretty big limitation.
Yeah.
The other one is effect handlers, which is something that is currently under research. It's something that we think we might be able to support, but we haven't been able to do it so far. I think, to give you a bit more detail, the way effect handlers work is they effectively unwind the call stack, and they sort of I think implementation wise in the OCaml backend, they're really doing like stack switching, like Golang does for their runtime.
Okay, I'm not familiar with that.
So if you think about exceptions, for example, right?
Mm-hmm.
Effect handlers, I think, are effectively resumable exceptions in the sense that you can throw something which unwinds the call stack, right? But then after you're done doing that operation, you can go back to where you were before.
Right. Yeah.
Right. And so there are a few ways, I think, to do this. One of them is stack switching. The other one is sort of like calling with continuations.
Yeah.
And so those are pretty big challenges for us in Melange. The first one being that we can't really do stack switching in JavaScript because we don't have that level of access. There is no there's no go-tos, there's no jumps that you can really do.
Yeah.
And the second one is this could probably be implemented with a continuation passing style or something like that. However, that would require us to add a new a new argument to every function that you defined when generating JavaScript code.
Yeah. Yeah.
And this breaks a pretty big assumption, a pretty big like contract in how Melange compiles your code to JavaScript these days, which is that the calling convention is the same between OCaml and JavaScript. So you can syntactically look at a function, let A that takes arguments B and C, and you can guarantee that you can call that function from JavaScript by calling A with arguments B and C.
So it's not just that I want the output code to look readable. It's that I want to be able to use it as though...
This is another...
I can carry my intuition across from the OCaml code to calling it from JavaScript. Yeah.
And we want to preserve that as much as possible.
Yeah. Switching everything to continuation passing would totally destroy that.
Absolutely. Yeah, exactly. And that leads us to, I'd say maybe like yet another challenge of how to implement a compiler from OCaml to JavaScript, which is how do you handle the boundary, right? And the boundary is always the sort of the most interesting part, right? When does the OCaml end and when does the JavaScript start? How do you call libraries that exist in the NPM ecosystem? They are exclusively written in JavaScript from your OCaml program that compiles to JavaScript. And how do you do, and vice versa, right? How do you compile something with Melange that you can call from from JavaScript, right? Sort of how I think the analogy for native here would be, thinking of Melange producing a dynamic or a static library that then you link against, right, in some other artifact of your
I might
code.
want to go and publish a package on NPM for JavaScript developers, but I don't really want to write it in JavaScript. Exactly.
You'd want to write it in OCaml. You want to run it through Melange. You want to publish to NPM and tell everyone, hey, here's how you call this package from JavaScript.
Yeah, and I don't want to ever admit that I wrote it in my favorite language.
That's right.
Yeah.
So this is another challenge where we talked a little bit about currying before, and currying is a pretty big challenge for these cases, and that is something that we can do some compiler optimizations during the compilation phase, but we can't really do that for all the cases, especially like all the dynamic cases where functions are passed around with each other. So currying does actually need to have a runtime when you're compiling Melange to JavaScript, or OCaml to JavaScript with Melange.
Okay, so hang on, I haven't quite got this. So in OCaml there is native currying.
Yep.
And you need to create an extra runtime in JavaScript land.
We do
to handle that.
Think of a list map, for example, where you're mapping over every element of the list of a list.
Yeah.
So the signature of list map in OCaml is is function, list, and result, right?
Yeah.
But you can choose to, and this is very common in functional programs, you can choose to partially apply the list map function to, right? You just pass it the first argument, which is the callback. And now you have a function that is a reusable function that can take any list and apply that transformation to any list.
Yeah. Yeah.
Right? How do you express this in JavaScript? Because in JavaScript, list map would be a function of two arguments, right? A callback and a list to a new list. And if you just pass one argument, the function is fully applied and the second argument is undefined.
Yeah. So you end up with this pattern where you write out like, I'm a function that takes I'm a function that takes one argument and then returns a new function that's going to wait for the next argument. If you want to do that in JavaScript land.
It depends.
You end up reinventing currying.
Yes.
Yeah.
It depends. As I mentioned before, right? Like we try to do the full application as much as possible, especially if we can figure it out at compile time, because that ends up being more performant than applying one argument and then getting a function and applying that argument again.
Yeah.
But we can't do this for all cases, which is why we also ship a runtime that you don't never have to worry about. But in some cases, Melange generates calls to this like curry runtime that handles this for you.
Okay. Yeah, because I would have thought it's almost impossible in the general case to recapture what the uncurried function was in the original source code. I would think
depends.
it depends. That's
Yes.
the unofficial motto of the podcast. It depends,
Exactly.
like any interesting question. Okay, so with all these difficulties, I think I'm required by hipster law to ask this question. You could have taken the other path where OCaml's compiling to the OCaml bytecode.
Yeah.
OVM, is it called OVM? I'm just guessing.
It's called the
It's not like the JVM, but for O.
I don't know if it's called OVM. I've never heard that before.
Okay, I'm making it up.
I think it's the name of the binary is camel run.
Camel run. Okay.
Okay. But I don't know what the VM is called.
Wouldn't you have fewer of these, like, making it readable problems if you stepped in at that point and said, instead of generating OCaml bytecode, we'll generate WASM?
Oh, interesting. So a new compiler backend for OCaml that generates WASM.
Yeah. And then you don't have to worry about readability because no one's worrying about it at all.
Right. This is, well, first of all, a great question, and it's a great point as well. I think there are a few projects underway. I'm not very familiar with the ecosystem there, or like what the players are, but I believe there are at least 2 or 3 competing projects to generate WASM from OCaml at this point. I can't tell you their names. I haven't kept up.
Fair enough.
But I know they exist. To answer your specific question, though, I don't think we're in a world still where that is desirable for everyone and their use case. From the perspective of, well, even if we ignore the technical limitations of, like, WASM doesn't have a GC and OCaml is a GC language. I think there's a proposal that's under works, or like it has just come out recently or something like that.
Oh, yeah. Or otherwise you'd have to start implementing a garbage collector in WASM first before you could do anything.
Correct. Yeah. And I think there are some projects who went in that direction. But the other reason, which I believe is a bit stronger, at least to me and my use cases, is that people don't really work with WASM directly, from my understanding. A lot of the code is still, or let's put it this way. WASM is sort of like, it generates like this black box for you. It was originally meant to be able to write these high performance programs like rendering engines and games, and have them run in the browser with minimal modifications. I'm not too familiar what the FFI, the interop story, looks like in WASM. Like, how do you call JavaScript functions from WASM, and otherwise, how do you expose like an interface from WASM to JavaScript? So this could be, my ignorance showing here, because maybe these problems are all solved and I don't know about them. Or it could be that the story is not that fully fleshed out.
Yeah, I'm not up to speed with it, but my impression is it's a bit more like doing RPC to a nearby but separate citizen.
Which makes sense to me, right? Because of the sandboxing requirements. So what you do get with Melange and like all the compile to JS, and why people are still doing compile to JS these days, is you get access to the entire set of libraries that exist on npm. You can call them and interop with them natively with code that is running on the same process, right, in the same thread. This is my understanding of the trade-offs.
Yeah. Okay. I think the market for actual JavaScript output is still very much there and will be for a long time, right?
I think so too. Like, I was trying to think how, and maybe this is something that I should go and look look up after the podcast, which is how do you write a React.js application in WASM, right?
I'm not sure you do.
I've never seen this, and I'm not sure you do either, right? And so, for the specific use case of, say, like Ahrefs, right, who have a specific use case of developing their React.js applications in OCaml using React.js, using Reason React, right? This is very much a use case that I'd like to see how supported in that scenario.
So if we zoom back out into that, what do I do today if I'm an OCaml developer wanting to write React? Is there like an OCaml library that looks a lot like React, or are there bindings into actual React? What does it look like?
Yeah, this is something that we touched a bit upon when I mentioned the boundary, right? The what happens when you want to call one thing from the other. I think I mentioned at the start of the episode how OCaml itself, right, when you're compiling to native, has an interesting interop story to see, where if you don't have this library available to you in the OCaml ecosystem, you can go and you can link to some C library, write bindings, and call into that C library.
Yeah.
In Melange, we actually use the same mechanism, but instead of C, we're calling out to JavaScript. So the way that works is you define the name of the function that you want to call. You define what the signature of that function looks like in OCaml terms. This is the unsafe part because you sort of have to guess, and JavaScript is very dynamic.
Right, yeah.
Right?
So it's on you to get the type signature of the JavaScript function correct.
It's on you, for sure, right? And then we added a PPX, right? Like that interprets a few attributes that generates all the constructs, that allows you to generate all the like syntax constructs that JavaScript has. For how do you generate like a new like object call? How do you define something on a prototype, right? How do you define a class? Things like that.
Yeah.
And so this is the approach that we took for React.js. There is the library called Reason React. This is a library that precedes Melange even, right? It was written when ReasonML, the project, started and was still using BuckleScript. We took it and ran away with it as well. So we use Reason React. It has a very nice PPX, right? Again, a preprocessor extension that interprets the ReasonML JSX, which is built into the language. And generates React like JSX or create element calls.
So what? I'm writing OCaml and I can include HTML tags through JSX.
This is if you write ReasonML, yes. ReasonML has had JSX support. But yeah, this alternative syntax for OCaml, right? It has, right? It was developed at Facebook with the goal of writing React.js programs in mind, sort of from day one. So JSX was included, and that's like a big selling point, right?
So I am writing OCaml, but it looks an awful lot like JavaScript and JSX, and it's outputting to JavaScript.
Yes, that's right. That's right. The thing there is the JSX in ReasonML is very much reusable from the perspective that, generalizable, right? From the perspective that if you wanted, you could write, say, your people in the general case use JSX to output React.js elements to the browser, right? That doesn't mean that it's the only use case for ReasonML's JSX. You could, for example, imagine your own pretty printer definition that uses JSX for tagging like pretty printing directives. Any sort of internal like DSL domain specific language that you can write with JSX. You can write it in ReasonML as long as you also write the sort of the runtime and the transformations.
Okay.
So it's like it's generalizable in that sense.
This is I mean, you could almost wonder where the OCaml is. It's very much under the surface in this stack, right?
It is, I'd say, yeah, it is very much under the surface at just the AST level, probably.
And what you're getting for that is a combination of the compiler, which is an advanced compiler, and the whole backend ecosystem when you actually start wanting to use Reason's server-side world.
Yeah, exactly. I'd say for the backend, if you're writing it in the backend, OCaml is very much everywhere in the scenario that we're painting. Otherwise, for the Melange part of the Melange part of the scenario, I would maybe say that OCaml is mostly just in the tooling, right? And then the surface looks a whole lot like JavaScript, and what you do get and what you run is definitely JavaScript.
Okay. So it seems like you are still blurring those lines between OCaml developers that want the browser and JavaScript developers that want OCaml.
I think that's a fair assumption. I think I am blurring those lines because I identify with both. And sometimes I need one of the use cases where I'm coming from one direction, and sometimes I need the other one where I'm coming from the other direction.
Yeah, I can totally see that. That's a good thing in my book. So why don't we, again, step back a bit and say, where do you come in as a user of this? Because you're doing all this work, but what does it do for you when you're not working on it? How have you put it to work?
Yeah. I have a few apps here and there. This is actually a very funny story because I think I found myself writing Melange and writing all the tooling around it because I wanted to use it. I wanted something to exist to write my own applications, because this would be my preferred way of writing JavaScript and shipping code on the browser, for example. What happened in practicality was that I found myself writing mostly the compiler and the tooling around it, and really never having time to go and then write my own applications.
Yeah, that's familiar.
So I have written some things here and there. I have some private private applications that I that are not out there. I have some things that I'm working on that are in Melange. I write Melange applications all the time to either in the form of compiler tests or otherwise to test out new compiler tooling. But I'd say there I don't think there's anything public out there other than maybe the Melange Playground, which it's melange.re/playground, I believe, which is an online playground where you can see how you can write OCaml on the left-hand pane and see the JavaScript that it generates on the right-hand side.
And is that sending the source code to a server and compiling
it? Is not.
Or it's all happening in the browser?
It is all happening in the browser. And so this is sort of where where I could maybe consider the Dr. Frankenstein, right? Having created the monster, where what we actually do is we compile. Unfortunately, Melange is still not self-hosted. So what we do is we compile Melange to JavaScript using JS of OCaml, which is the other player in the OCaml ecosystem. And then we have this big bundle of code that is the Melange compiler. And then that we just treat as sort of a black box. It has an interface that allows you to feed in OCaml or ReasonML and get out some JavaScript compiled by Melange. And then we put a Melange web application around it.
Right.
So it's an organ
Right. Okay. And you're going to have to remind me now you've brought it up. So why you're using JS of OCaml to compile that that this is a hard enough question to phrase because it's so meta. You're using JS of OCaml to compile the Melange compiler to JavaScript.
This is correct.
What's the drawback of the JS of OCaml compiler that makes you still want to write Melange?
For sure. I think this is a great question, and sort of one of the reasons why Melange exists at all is why is JS of OCaml not sufficient for our use cases? There are a few reasons. One of them is I mentioned before how Melange hooks into the Lambda layer, right? The Lambda intermediate representation, whereas JS of OCaml takes the OCaml bytecode and interprets that at compile time to generate JavaScript. There are a few trade-offs that have to be made when you don't have all the information that you have at the Lambda representation that has been lost between that and the bytecode.
Yeah. Information gets thrown away to get there.
Exactly.
Yeah.
So we talked a lot about how we represent OCaml structures in JavaScript when compiling through Melange, how that affects readability of the generated code, and the different structures that you can then work with to generate JavaScript. Mm-hmm. So one of those is, for example, how I'll go with the records example again, where naming information for the keys is just not preserved between one and the other, right? Yeah. For example, so you can't represent those as JavaScript objects, for example, if you're going through JS of OCaml. There's all these particularities about mostly around representation of OCaml constructs in JavaScript, and then how that also affects performance. If you don't have all the information available, you need to add a lot more indirection and add a lot more runtime if you're going with the latter case, right?
Right. Yeah.
Is it the big advantage though, right? Because I only mentioned trade-offs, but JS of OCaml has a lot of advantages over Melange as well, right? Because in engineering, everything is always about trade-offs. You can really have exactly one solution that is strictly better than the other, or those cases are very few. Mm-hmm. So the big advantages that JS of OCaml offers is the ability to support most, if not all, the OCaml language, right? I mentioned before that how it's there's some modules, some standard library modules, and some other libraries, some constructs that we can support in Melange. I talked about effect handlers, for example, right? And that is something that JS of OCaml does support. I think the route, for example, that they took is they added the continuation argument to the end of every function if you're compiling effect handlers. But this means that every function in your program needs to have this last argument, and then if you want to call that from JavaScript, you need to provide an adapter so that you know how to call that, right? So again, you're incurring runtime, and the representation isn't as trivially understood or documentable even. But then the big advantage is that you support a whole lot more.
Right. Yeah. So in a way, you could separate it out as you're compiling, in Melange, you're compiling still a fairly high-level language to another high-level language, whereas in JS of OCaml, you are basically bytecode to different bytecode.
I think that's a great way of putting it. Absolutely.
Yeah. Okay, I can see the trade-offs. So let's zoom out then to the practicalities of someone else using this. If they've decided, because certainly I'll put my cards on the table and say I don't want to write JavaScript. I'm happy to say that.
Fair.
I may want to write TypeScript, and I have very different feelings about TypeScript and JavaScript. But I like writing pure script. If I wanted to say, okay, let's go ReasonML, try this out, and see how it feels to me, what's the best way to get started?
I'd say the best way to get started is going to melange.re. It's a website where we've put our getting started instructions. We put all the documentation. There's a very big section on like how to, because I'll make this aside. I'd say like you don't want to write JavaScript, but I think you'll still find yourself working with a lot of JavaScript if you're shipping to a JavaScript platform. So you'll have to do interop with JavaScript on every platform, even if just the platform APIs, right? At some point, you'll need to call them. So you have a long section of where we document how to do all of that, how to write your the code at the boundary, how to consume libraries, how to orchestrate the builds. You can also join the OCaml Discord or the ReasonML Discord. We're always there. We try to be online as much as possible, help you out. That's, I think, the best way to get started.
Cool. And I mean, this is a really hard question to give a specific answer, but give me your subjective opinion. How mature is this stack?
This is a hard question. I think give you a bit of history, maybe. I think maybe 2-3 years ago, we started from a point where effectively what we had was pieces like this disjointed set of tooling, right? Just pieces that existed. You could sort of put them together, but you'd have to do everything manually yourself. A big part of our work from 2-3 years ago until now has been, how do we put all of these things together behind the scenes so that you mostly don't have to worry about that yourself? And so we added support for Melange in the OCaml build system, made it work seamlessly with the OCaml platform, and have been really fixing a lot of code along the way. We're at a point where we've shipped 4 major versions of Melange. Okay. And we have, I'd say, a lot of users using Melange in production these days. The biggest one being Ahrefs.com, as I mentioned. So I'd say it is stable, right? From the perspective of you can ship it to production and not expect any like major surprises surprises coming from like your like choice of tooling in this case, right?
Yeah.
Which is where you want to be at, like on anything that you depend as critical infrastructure effectively. However, I'd say the ecosystem is still very young. You'll find that if you ship Melange, I'd say we're still maybe in the early adopter phase where the ecosystem is not totally there. You'll find that you'll have to write a lot of bindings to JavaScript libraries that exist on NPM. You'll have to maybe write 1 of 2 libraries yourself to do what you want. You'll have to figure out how you're going to configure your build and like where Dune and OCaml and where like a bundler takes over, for example. And those are all choices that you'll have to make yourself. And we don't have like any recommendation for, right? So there's a lot of figuring out. There's a lot of fiddling, but overall, like the core, let's put it like this. Like, I think if you're experienced with OCaml, you'll be familiar with the Melange tooling. If you're new to OCaml, there's a lot to learn.
Okay. That's fair. That's kind of what you'd expect, right?
Yeah.
Okay. So that raises perhaps a final question, because I'm assuming you're not now going to focus on writing native React ML date pickers. You're not going to run off and flesh out that ecosystem. What is your future for this project? What are you working on in the next 6 months, year?
Absolutely. So there are a few things that we want to achieve. One that is always top of mind is developer experience. So we have a front end team right inside Ahrefs that is working with Melange and ReasonML every day. They feel pain points, right? And those pain points are reported back to me upstream, and this is something that is always something that we need to keep in mind. So we need to not only fix bugs and like the usability of ReasonML, the language itself. We need to fix bugs that arise with using Melange. Not only like code generation bugs, which these days are few and far between, but mostly around if your compiler gives you an error message and you don't know what to do with it, like whose fault is it, right? Usually it's the compiler because the message is not helpful. So there's a lot of work in developer experience that we're focusing on. We're also trying to really ship this project that makes it easy to share code between the front end and the back end, right? Between code compiled with Melange versus or in addition to code compiled to native. Like, how do you define these like language specific constructs that you alluded to earlier of like sort of like Clojure calls them reader conditionals. I kind of like that phrasing quite a bit. But basically, these compiler directives that conditionalize the backend that you're compiling to. And then the rest of the work that we need to do is how do we support increasingly more JavaScript constructs in the Melange side. The one that I'm thinking of specifically is like dynamic imports. You know how in JavaScript you have, I'll simplify it, like two types of imports. One that is synchronous. This is the one that you put at the top level of your file as a declaration. I want to import these values from another module. But you also have these dynamic or async imports where you can choose to import some other module or another bundle at runtime. And that is bundlers usually like hook on that construct to sort of define where they do bundle splitting. So like, I'll ship like a chunk that is the main application chunk. And then if this imports something else dynamically at runtime, like I'll put that in like a different logical chunk that doesn't have to be part of the main bundle when you load a web page. So this is something that, for example, is very much on the Melange roadmap, and it's something that we're working on, and we're trying to provide a solution that is idiomatic in OCaml while still giving you the benefits of bundle splitting in JavaScript.
Okay, yeah, that it's interesting. That particular point gives a real sense of where you are on the maturity curve,
right?
Because that's the kind of thing you only start to worry about once the compiler is actually stable and people are building stuff and shipping large enough projects.
It's a fair point, and you can do it these days, right? The work that we're trying to do is how to make it idiomatic, because Melange has effectively an escape hatch where you can write JavaScript code within your ML file, right? And using that, or even using the FFI language, the interop language, you can make dynamic import work. And I know of people who have of code bases that are making it work with Melange. It's just that you lose a lot of safety. We talked a little bit about OCaml modules and how like they're very well typed. You can define signatures for them. So to give you like a little bit of, I guess, a preview of what's coming and what we're working on is the ability to define a signature or infer a signature that you import dynamically. So that when you do import your OCaml module dynamically, everything is still type safe, and it's as if you were just referring to another module that exists within your OCaml code base.
Right. Yeah.
That's really like the interesting part of the work is like, how do we generate a dynamic import for something that we don't include in the bundle? But how is like, it preserves the type checking, it preserves the signatures, and you're not like programming in an unsafe way.
Yeah, because you don't want to lose the guarantees of the language, and you definitely don't want to make this something that becomes hard in developer space.
Absolutely.
Yeah. Well, that sounds like a very fun piece of work to be working on.
It is. Yeah, it is. It is very fun. It is. There's a lot of research. There's a lot of prototyping, but I think we have some parts figured out.
Well, I best leave you to go and carry on with it.
That sounds good.
Thanks very much for taking me through it.
Thank you so much for having me on. This was great.
Pleasure. Cool. Cheers. Thank you, Antonio. So the first thing I should say before we go is if you want to support Antonio's work, you can sponsor him on GitHub. There's a link to that page in the show notes below. Also, consider getting your company to sponsor him instead, because a large amount to an independent open source developer is a rounding error to the average company's IT budget. So if you can persuade the right person, do that. It'll be great for everyone. While we're on that topic, I should probably say there is a link to the Developer Voices Patreon account if you would also like to sponsor future episodes of this podcast and keep the show running. And of course, the show notes are the right place to look for those links and any links to the projects we discussed during this episode. So go look there for all your link goodness. We'll be back next week with another brilliant mind from the world of software development, so make sure you're subscribed. And if you enjoyed this discussion, please give it a like and maybe share it with a friend. Anything else? Yes, if you have any suggestions for future guests, you can find my contact details. Please get in touch. I'm working through the backlog, but I always like more suggestions, so I'd love to hear from you. Thank you. And with that, it just remains for me to say, I've been your host, Chris Jenkins. This has been Developer Voices with António Montiero. Thanks for listening.